Okay, so the last topic for us to look at in this lesson deals with even and odd functions. So we're going to talk about like how we define even and odd functions, how we algebraically show whether functions are even or odd, and also what a function being even or a function being odd tells us about the graph of that function. Okay, so a function f is even if for every number x in its domain, the number negative x is also in the domain, and if we take the opposite of the input value, okay, if we take f of negative x, then that's going to be equal to the original function that we started with. Okay, so when we take f of negative x, it gives us back the original function we started with, f of x. If you have a function that is even, then that tells you that the graph is going to have symmetry with respect to the y-axis. Okay, so even functions have symmetry with respect to the y-axis. And a function f is odd if for every number x in its domain, the number negative x is also in the domain, and when you take the opposite of the input value, okay, when you take f of negative x, it gives you back the opposite of the original function you started with. Okay, so when you take f of negative x, it gives you an output of negative f of x. And odd functions have symmetry with respect to the origin. And we'll talk about what that means in 1 second. Okay, so real quick, an example of an even function. We have the function f of x equal to x squared. We know graphically that that's a parabola whose vertex is at the origin and opens upward. And that graph, when you look at it, it has symmetry with respect to the y-axis. You get an equal image on each side of the y-axis. Okay, now if you took like some point on that graph in quadrant 1, let's say we have like the ordered pair 2, 4. If we take the opposite of the input value, so let's say we take the opposite of the input value, -2. When I input -2 into that function, it also gives me an output of 4. Okay, so the point 2, 4 and -2, 4 are going to be on the graph of that function. An example of an odd function is f of x equal to x cubed. So graphically, that function is going to look like this in quadrant 1. Now, when we say that odd functions have symmetry with respect to the origin, what that means is if you were to take that part of the graph in quadrant 1 and do a y-axis reflection, which would like dash in this part of the graph here, and then do an x-axis reflection, that's going to be the image for the rest of that graph. Okay, so if you take a portion of the graph, if it has origin symmetry, when you reflect it across the y-axis, then reflect it across the x-axis, you should get an equal image. Okay, if we take, let's say, the ordered pair 1, 1 on the graph of the function, if your graph has origin symmetry, when you take the opposite of the input value, so when you take the opposite of the input value, -1, it should give you the opposite of the output value as a result. So if the point 1, 1 is on the graph, when I take the input value of -1, the opposite of the output value, so the opposite of 1, which is -1, should also be on the graph of that function. Okay, so the last set of examples for us to look at are going to have us determine if the function is even, odd, or neither. Okay, so the way we algebraically do this is for our function, we want to take the opposite of the input value and see what we get as a result. Okay, so when we take the opposite of the input value, g of negative x, when I plug negative x in the place of x in my function, that gives me this. So we have negative x to the power of 3 minus 5 times negative x. So negative x raised to the third power becomes negative x cubed. And negative 5 times negative x becomes 5x. Well, it's pretty obvious that that does not give me the original function that I started with. So that function is not even. Does it give me the opposite of the original function I started with? And the answer is yes, because if I factor a negative 1 out from these terms, we get x cubed minus 5x, and that is the opposite of the original function g of x. Okay, which means that the function here is odd, and if the function is odd, that means the graph has origin symmetry. Okay, when we do the same thing for number 2. Okay, for number 2, we're given f of t, which is equal to t to the 4th power plus 7t. When I take the opposite of the input value, okay, so we're going to take f of negative t. We want to see what we get as a result. So we're going to plug in negative t wherever we see a t in our function. So negative t to the 4th power is the same thing as t to the 4th power plus 7 times negative t, that becomes minus 7t. Okay, so that is not the original function that we started with, so the function is not even. That's also not the opposite of the original function we started with, so the function is not odd, which means that this function here is neither even nor odd, which means that the graph has no symmetry. Okay, it doesn't have y-axis symmetry, and it doesn't have origin symmetry. Okay, I'm going to have you guys try numbers 3 and 4. So go ahead and get those 2 examples copied, and then go ahead and pause the video while you work on those, and then we'll talk about those together. Okay, so I already saw a simple mistake that I made. It's not a big deal, but this should be f of t, not f of x. So f of t is equal to t cubed divided by t squared plus 1. We're going to test to see if the function is even, odd, or neither. So we're going to take f of negative t, we're going to take the opposite of the input value, which gives us negative t cubed over negative t squared, negative t quantity squared plus 1. So when we do that, that becomes negative t cubed over t squared plus 1. Okay, so pretty clear that this function is not even. Okay, it doesn't give us the original function we started with. Let's check and see if it's odd. Okay, but before I do that, let's talk about fractions really quick. Let's say we have the fraction 1/7. What is the opposite of 1/7? The opposite of 1/7 is negative 1/7. What are the 2 ways that we can write negative 1/7? Well, the 2 ways that we can write negative 1/7 is negative 1 over positive 7 or 1 over negative 7. Okay, so with that said, isn't this function here, isn't it the opposite of f of t? Because we are taking the opposite of the numerator and the denominator stays exactly the same. Okay, so that function is the opposite of f of t, thereby making the function odd, and thereby making it, the graph, have origin symmetry. Okay, let's look at 4. So for 4, we're given h of x equal to x cubed minus x to the 7th power over x to the 5th power plus x. Okay. So to test to see if the function is even, odd, or neither, we're going to take the opposite of the input value, which is going to make this become negative x quantity cubed minus negative x raised to the 7th power over negative x raised to the 5th power plus negative x. Okay, so let's see what this becomes. So negative x raised to the 3rd power is negative x cubed. The opposite of negative x to the 7th is going to become plus x to the 7th over the opposite, the opposite of x raised to the 5th power is negative x to the 5th plus the opposite of x, that's minus x. Well, when you look at what you have here, like, it kind of resembles the function h of x that we started with, but the problem that we have is, like, we have the opposite of every term in the numerator over the opposite of every term in the denominator. Okay, so, like, I can rewrite the numerator as the opposite of x cubed minus x to the 7th. And if I factor a negative 1 out of the denominator, we get the opposite of x to the 5th power plus x. Don't those two factors of negative 1 cancel one another out? So this gives us x cubed minus x to the 7th over x to the 5th power plus x. That is the original function we started with, h of x, thereby making this function even and making it have y-axis symmetry. Again, like, if you were confused by that, let's think of, like, fractions. Okay, if I had the fraction 1/2, isn't another way for me to write the function, like the fraction 1/2, as negative 1 over negative 2? Those two fractions are equal to one another. If I take the opposite of both the numerator and denominator, those two factors of negative 1 on top and on bottom cancel one another out, which gives me the original function that I started with. And that's kind of like what's happening with example number 4 there. All right, so that wraps up that lesson, guys. Please make sure you have your homework assignment done for 1-2 before the block synchronous meeting this week. All right, we'll see you guys in class on Monday. Hope you had a great weekend. Bye-bye.